Hey guys, in this video we're going to talk about converting between fractions, decimals, and percentages. So what is a fraction? A fraction just represents a part of a whole. And we have two parts of a fraction. The first part is the numerator, that's the top number. That's how many number of parts we have. And the second part is the bottom of the fraction, that's the denominator, how many parts are in the whole. So let's just look at some examples here. So 2 out of 5. 2 out of 5 is how we say this. And we say this as 2/5. All right, and we can look at this pictorially. So notice that the total number of parts, 1, 2, 3, 4, 5, there's 5 parts, so that's our denominator. And the parts that are shaded is the numerator. So 2 out of 5 parts are shaded. We can also look at a picture like this. This time, again, we have 1, 2, 3, 4, 5 total parts. That's going to be on the bottom. And how many are shaded are going to be on the top? It's going to be 2. So 2 out of 5. So all three of these pictures represent the fraction 2/5. So let's do some practice. We want to name the fraction in words and as a number, so with a top and a bottom. All right, so for this first one, we count the number of pieces, 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 total pieces in the denominator. And how many are shaded? Well, we have 1, 2, 3 pieces are shaded, so that's the numerator. So that's our fraction as a number. And in words, this is 3/8. Okay, let's look at number 2. Let's first count how many pieces we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal pieces. And how many are shaded? Are 1, 2. So that's 2/10. Let's say it in words. 2/10. Okay. Now let's look at number 3. We have 1, 2, 3, 4, 5 total pieces. And how many are shaded? Well, they're all shaded. All 5 are shaded. So all 5 are shaded. And you'll notice that 5 out of 5 equals 1 whole. All right. So 5 out of 5, we can say this is 5 for the numerator, and then the denominator is fifths. 5/5. All right. Looking at this last one, we have 1, 2, 3, 4, 5, 6, 7, 8 total parts. And how many are shaded? 7. So how do we say this in words? On top, we have 7. On bottom, we have 8ths. Okay? So equivalent fractions represent the same amount even if they look different. So just on, if you imagine a pie, basically equivalent fractions, if we talk about half of a pie, half of a pie is the same thing as 2/4 of a pie. We're just, making the cuts look different. And that's the same thing as 3/6 of the pie. It's the same thing as 4/8 of the pie. These are all the same amount of pie. So that's what equivalent fractions are. We just divvy up the pieces differently. So how do we find equivalent fractions? We can multiply or divide the fraction by a number. So, and the reason, so like if we have 1/2, for example, if I multiply this by 3/3, this is the same thing as multiplying by 1. That's what I'm saying right here. Number divided by number always equals 1. So we're not changing the amount, we're just changing the look of it, right? When we multiply by something that equals 1. So 1/2 times 3/3, aka 1, if we multiply straight across, 1 times 3 is 3, and 2 times 3 is 6. So therefore, 3/6, so So therefore, 3 over 6 is equivalent to 1/2. So that's one of the equivalent fractions we found. And there's an infinite amount of numbers that we can multiply or divide by, right? So what else? We want to find 3 fractions. How about if I multiply by 4 over 4 this time? That's the same thing as multiplying by 1, right? A number divided by itself. So if I multiply straight across, I get 4 over 8. So therefore, 4 over 8 is also equivalent. 4 pieces out of 8 pieces of pie is equivalent to 1/2 of a pie. All right, so we found our second one. And for our third one, well, again, we can just find a random number to multiply by, top and bottom. So how about I multiply by 2 over 2? Well, if I multiply 1/2 by 2 over 2, I get 2 over 4 multiplying straight across. So therefore, 2 over 4 is equivalent to 1/2. And there's an infinite number of numbers that we can multiply by, right? We can multiply by 1,000,000 over 1,000,000. That still equals 1. So another equivalent fraction of 1/2, we could multiply by 1,000,000 over 1,000,000. And when I do that, I get 1,000,000 over 2,000,000. So this is also equivalent to 1/2. There's an infinite number of equivalent fractions for a given fraction. All right, so for each fraction, find 3 equivalent fractions. So again, I'm just multiplying by a number, top and bottom by a number. So the first one, we could do 2/3. I'm just picking easy numbers. How about 2 over 2? That's going to be 4 over 6, so that's one equivalent fraction. Then I can multiply, just picking the next most obvious one, by 3 over 3. That's going to give us 6 over 9, so that's also equivalent to 2/3. And then 2/3 times, I could do 4 over 4. Just the next smallest one, multiplying straight across, I get 8 over 12. So all 3 of these that I've circled are equivalent to 2/3. Now let's do this one right here. 7 over 7. I don't have to multiply by a constant number. I can also divide, right? If I have 7 over 7, I can also divide by 1 to get an equivalent fraction. So I can actually divide by 7 over 7, right? 7 divided by 7 is 1. 7 divided by 7 is 1. So 1 is equivalent to 7 over 7. Okay? You can also, multiply. So 7 over 7 times, let's say, 2 over 2 is 14 over 14. That's also equivalent to 7 over 7. Also equivalent to 1. And maybe I'll pick another number. How about 3? 7 over 7 times 3 over 3, which is going to be 21 over 21. So 21 over 21 is also equivalent to 7 over 7. Okay, let's talk about decimals. So a decimal number represents parts and wholes just like a fraction does. And this is the way that we set up parts and wholes with decimals. So we have thousands, hundreds, tens, and ones to the left of the decimal point, and to the right, in the next spot, we have tenths, followed by hundredths, followed by thousands. So for example, we have this number 5,162.341. If we follow this chart here, we have 5 in the thousands spot, plus 100, plus 6 tens, plus 2 ones, plus 3 tenths, plus 4 hundredths, plus 1 thousandth, okay? And we can write 5 thousands as 5 1,000, 100 as 100, 6 tens as 60, 2 ones as 2, 3 tenths as 3 over 10, 4 hundredths as 4 over 100, and 1,000th as 1 over 1,000. Okay, so rounding, basically we take a number and we cut it off in the spot where we want to round to. So for hundredths, we're going to have this number have 2 places after the decimal point, just like our chart tells us. We want hundredths to be 2 places after the decimal point. And we look to the number to the right of it. If it's 5 or bigger, we round up. If it's smaller than 5, we round down. So for example, if we're rounding to the nearest hundredth, we're trying to cut it off here, right? We want 3.6 something. But this guy goes up to 5 because the number to the right of it is greater than 5. So this gets cut off as 3.65. Okay, we look to the right of where we're cutting this thing off to see if we need to round up a number or keep it the same. All right, let's look at the next one. Round 112.63 to the nearest 1. So our ones place is right here. So we look directly to the right of it. And since 6 is bigger than or equal to 5, we round the 2 up to a 3 and we cut it off. So this is the 1 spot. So we have 113 and that's cut off there. Okay, 7,542.6781 to the nearest thousandth. This time we want to cut off right here. And we're actually going to keep that thousandths number the same, that third number after the decimal. We're keeping it the same because 1 is smaller than 5. Okay, so we keep that the same. If it was bigger than 5, we would round up to 9. So this is going to be 7,542.678, and that's where we cut it off, our thousandths. The nearest tenth, we want to cut off right here. And the number directly to the right of 2 is 3, which is less than 5. So we just keep it as 0.2. We don't round it up to 0.3. That's our rounding to the 10th spot. And to the 100th spot, we want to cut it off right here. Should we round 6 up to 7? Yes, we should, because the number directly to the right of it is bigger than 5. So when we cut this off, we have 1,672.47. That's round to the nearest hundredth. All right, so let's do some examples where we're converting between fractions and decimals. So going from fractions to decimals is easy. We just use the calculator. We just do the division. So the fraction bar means division. So 3 over 4 is 3 divided by 4, and in your calculator you should get 0.75 as a decimal. Okay, 5 over 6 is the same thing as 5 divided by 6. So 5 divided by 6 is 0.83. Okay, so that's how we go from fractions to decimals. Pretty easy, just using a calculator. Now, if we want to go from decimals to fractions, we need to basically see where it terminates, it ends. So it ends in the hundredths spot here, which means we're just going to put that number over 100. All right, so this is 50 over 100. What would this be? This terminates in the 10th spot, so it's 7 over 10. This guy terminates in the thousandths spot, so it's going to be 140 over 1,000. And then we just simplify as much as we can. So remember, when we simplify, we can either multiply by a number over itself, or we can divide by a number over itself to get equivalent fractions. So here I can divide top and bottom by 50. That's equivalent. And that's going to give me 1 over 2. And then you just want to keep dividing until you can't anymore. 1 over 2 you can't divide anymore. 7 over 10 we can't divide by anything. to make it simpler. 140 over 1,000. If I first divide by 2, half of 140, half of 50, half of 40, half of 100 and half of 40 together is 70. So this is 70 over 500. And then if I divide by 2 again, we can keep dividing by 2. This is going to give us 35 over 250. And then, let's see, 35 out of 250. I can divide by 5 to get 7 over 50. And then I can't go anymore, so that's my fraction in simplest form. All right, let's talk about percentages now. So percent means part of 100. So basically, if we have a percent number to make it a fraction, we just put it over 100. So here we have 70%, which means 70 over 100. So this is how we write it as a fraction, and we could simplify it if we wanted to. How would we write it as a decimal? Well, we would just put it in the calculator. 70 divided by 100 is 0.7. So this is a fraction, and this is a decimal. All right, number 2, 35% is just 35 out of 100. And if I put this in the calculator, 35 divided by 100, that's 0.35. So this is fraction and decimal. 100%, that's 100 over 100, which is 1, right? And then, as a decimal, it's just 1. If we put 100 divided by 100 in the calculator. 120%, we have 120 over 100 equals, in the calculator, 120 divided by 100 is 1.2. So decimal and fraction. And we can simplify these fractions if we want to by, continuously dividing top and bottom by the same number. But I'm not going to do that here. All right, so how do we go from decimals to percents? Well, we can kind of set it up like this. The decimal number is some percent over 100, And so basically, if you just multiply 100 on both sides of this equation to clear out that 100, we get that the decimal number is equal to, decimal times 100 equals the percent. So basically, we're just multiplying by 100. So 2.34 as a percent, we just multiply by 100, basically move the decimal 2 places to the right to get 234%. Here, multiply by 100, we move the decimal 2 places to the right or do it in the calculator to get 400%. Here, 2 places to the right. So that's going to just be, if we multiply by 100 in the calculator, you get 4%. It should be a point. So if we move 2 places to the right, we get 0.4%. Okay, so in this video, we're going to talk more about adding and subtracting fractions and look at mixed numbers and improper fractions. And we're going to talk about order of operations, aka PEMDAS. So the first thing is adding and subtracting fractions. Now, if I asked you to tell me half of a pie plus 3/4 of a pie is, it would be kind of hard to visualize, right? So the idea is we want to change one of these fractions to have the same denominator as the other. So I want to look at changing 1/2 to have 4 as the denominator so that I can add these easily. All right, so 1/2, we need an equivalent fraction. We need to multiply 1/2 by something so that the bottom is 4. Well, to get 4 on the bottom, we have to multiply by 2. So I have to multiply top and bottom by 2. So 1/2 as an equivalent fraction is 2/4. 1/2 is the same thing as 2/4, right? So half of the pi can be written as 1/2, or it can be written as 2/4, or 4/8, or 3/6, or you guys get the idea. So instead of saying half of a pi plus 3/4 of a pi, what we can now say is we can say 2/4 of a pi plus 3/4 of a pi. Well, when you say it out loud, 2/4 plus 3/4 is how many fourths? That's going to be 5/4. So that's our answer here. So before we add and subtract fractions, we need to have the same denominator. Let's do some examples. 5/8 plus 3/4. So which denominator are we going to change? Are we going to change the 8 or the 4? Well, we want to change the smaller one. So we want to change the 4 into 8. So 3/4, we want to have a denominator of 8. So this is the one I'm working on. And 4 times 2 is 8, so I can multiply top and bottom by 2 to get an equivalent fraction. 3/4 is the same thing as multiplying straight across 6/8. All right? So this problem becomes 5/8 plus 6/8. 3/4 is 6/8, same thing. Adding straight across, 5/8 plus 6/8 is 11/8. So that's our answer. Let's do another example down here with subtraction. 9/10 minus 1/5. So which denominator am I going to change? This one or this one? Well, I want to change the smaller one into the bigger one. So let's go ahead and change this guy. So I start with 1/5, and I want a denominator of 10. So to get 10 on the bottom, I better multiply by 2 on top and bottom. So 1/5 is equivalently, it's a hard word to say, equivalently 2/10. 1/5 is 2/10. So I can replace that here. 9/10 minus 2/10 is equal to how many tenths? Well, that's going to be 7/10, and that's my answer here. I encourage you to pause the video and try this next one on your own. So, looking at the denominators, we have 16 and 8, and we want to change the smaller into the bigger. So I want to change this guy again. So 1/8, I want to have a denominator of 16. So I better multiply the bottom by 2 and the top. So when I do that, I get that 1/8 is equivalent to 2/16. So rewriting, I get 7/16 minus 2/16. Well, 7 of something minus 2 of something is going to be 5 of something. So we get 5/16. All right? I hope that made sense. Okay, now we're going to talk about mixed numbers. Basically, mixed numbers are just fractions that are bigger than 1. So like 3/4 is smaller than 1, right? 4/4 is a whole. But 3/4 is just a part of a whole. And we've just been looking at those types of fractions. Those are called proper fractions. Improper fractions and mixed numbers are the same. They mean the same thing. They're basically representing something that's more than 1. So like in this case, this means we have 8 pies and a half of a pie, right? Or equivalently, we can say 17 half pies is the same thing as 8 pies and a half pie. All right, so there's a pretty easy trick that you'll need to know for the t's to go from mixed to improper. And the trick is that you basically multiply the bottom number by the big number, and then you add the top number to get the new top number. And then you just keep the denominator as it is. So let's do some examples with this. You can think about it conceptually too. I mean, 8 1/2, we can draw it out, really. We can draw out 8 pies. 1, 2, 3, 4, 5, 6, 7, 8 pies. And then we have a half of a pie. So really we have this. And then we have just half right here. So this is 8.5. Now, if I want to just write it in terms of halves, I can just cut all these things in halves. Like 8, right? So 8, I just cut everything into half, that's fine. And then I count how many halves I have. Well, I got 2 halves here, right? 2 halves here. 2 halves here. You see where this is going? 2 halves. 2 halves 8 times. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. I can't count, you guys. I think that's 8 of these. 1, 2, 3, 4, 5, 6, 7, 8. And then finally, this guy represents just a half. So each of those whole circles are 2 halves, and then we have 1 half. So 2, 4, 6, 8, 10, 12, 14, 16 halves. Is the 8 filled in pies plus that lonely half over there. Well, how many is that? That's 17 halves. That's pretty cool, right? All right. But, and when you're taking the test, you might not have time for all that business. So we can use a shortcut. So again, the shortcut tells us I multiply these two numbers. So I get 28. Then I add the numerator, which is 1 in this case. All right, so let me do this again. We get 28 plus 1 divided by, the same denominator. So this is 29 over 4 as an improper fraction. What about this guy? Well, 3 times 2 is 6. 6 plus 1 is 7 over 2. So this is 7 halves. All right. Now let's do some examples. So the easiest way I think to do these is to change to improper first and then to just find the equivalent fraction like we did before. So I'm going to first change this. 3 times 2 is 6 plus 1 is 7 over 2. So 3 halves is the same thing as 7 halves. 2 and a 6. 2 times 6 is 12 plus 1 is 13 over 6. So 2 and a 6 is 13/6. And then we can find a common denominator. So looking at these two, we're going to change 2 into 6. So we're going to actually change this guy into 6. Okay, so 7 over 2, we want to have a denominator of 6. So I have to multiply top and bottom by 3 to get 21 over 6 is the same thing as 7 over 2. So 7 over 2 we just said was 21/6 plus 13/6 is equal to 34/6. So that's our answer. All right, now we have a proper fraction, no big deal there. And then this is a mixed number, so we can change that guy. So 3 and a 5th. 3 times 5 is 15. Plus 1 is 16. So this is secretly 16/5 plus a 14th. So this is our problem. We got 1/14 we have 1/14 plus 16/5. And we want a common denominator. And it might not be obvious what the best equivalent fraction to make is, but we can't really turn 5 into 14, right? 5 times what is 14? Some weird decimal. So what we can do instead is we can just multiply these numbers and use that as our equivalents. So let's see. 14 times 5 is 70. So whenever this happens, we can actually change both of these with a denominator of 70. So, that's what we're going to do. So 1/14 is equal to what? over 70. Well, we just said we had to multiply by 5. So 1/14 is secretly 5 over 70. So 1/14 is secretly 5 over 70. And then what's 16/5 with a denominator of 70? Well, let's see. 16/5 with a denominator of 70. This time I have to multiply the bottom by 14. So I do the same thing at the top, and 16 times 14 is going to give me 224. So 16/5 is secretly 224 over 70. And now we have common denominators, and we can just add straight across. So 224 plus 5 is going to be 229 over 70. And that's my answer. Maybe I could simplify or something like that, but that's good enough, I think. Okay, now we have 5 1/6 minus 1 1/3. Changing this guy to an improper. This is 5 times 6 plus 1. So that's going to be 31 over that same denominator minus this guy is 1 times 3 plus 1. So it's 4/3. Now this is a nice problem because I can change 3 to 6. It wasn't like the problem before where 14 and 5 didn't have any common multiples. But here we do. We can turn 3 into 6 pretty easily. So 4 over 3, I want to have a denominator of 6. So I better multiply top and bottom by 2 to give me 8/6. So this turns into 31/6 minus 8/6, right? And 31 minus 8 is just going to be 23. So this is 23/6. Adding and subtracting fractions. Very nice. Okay. Okay, so multiplying and dividing fractions is actually easier than adding and subtracting. So for multiplication, we can just multiply straight across. So for instance, 2/3 times 4/9. If we multiply straight across, 2 times 4 is 8, and 3 times 9 is 27. Okay. Now for dividing, what we do is you can remember it as keep, change, flip. So we keep the first fraction. So in this example, we're keeping 2/3 as it is. Then the second part says change division of multiplication. So we do that. And then it says for the third part, we flip the second fraction. So 4 over 9 flipped is just 9 over 4. And we can multiply straight across to give us 18 over 12. And if I wanted to find an equivalent fraction in lower terms, I could just divide this guy by common factors, right? So I know that 18 and 12 are both divisible by 3. So an equivalent fraction here would be 6/4. And I can go even lower than that. 6 divided by 2 and 4 divided by 2. Well, 6 divided by 2 is 3, and 4 divided by 2 is 2. So in simplest terms, 2/3 divided by 4/9 is 3 over 2. Let's do some practice. So 3/4 times 2/8. Well, this is multiplication, so I can just multiply straight across. 3 times 2 is 6. 4 times 8 is 32. If I want to put it in simplest form, I can divide top and bottom by 2. 6 divided by 2 is 3. 32 divided by 2 is 16. And I don't think we can go more simple than that. All right, for number 2, same thing, multiplying straight across. 1 times 3 is 3. And 9 times 16 is 144. And 144 is actually divisible by 3. So if I divide top and bottom by 3, this is going to give me a simplest answer of 1 divided by 48. Can't divide any more than that. The next problem is a division problem. So keep, change, flip. So I keep the first, change, division, and multiplication, and flip the second fraction to 12 over 7. Multiplying straight across, I get 12 over 28. And in simplest form, I can divide top and bottom by 4. I know those both go in a 4. 12 divided by 4 is 3. And 28 divided by 4 is 7. So that is my answer in simplest form. All right, let's see the next one. 4/5 divided by 7/8. I have 4/5, keep, change, flip. Okay. Multiplying straight across, I get 32 over 35, and I don't believe that can be simplified anymore. So that is that. And one little trick that might be helpful is that you can always tell if it can be simplified if you look on the diagonals. Like, so the diagonals 5 and 8 can't, they don't have any common factors to divide out. Like 5 and 8 are co-prime, that's what we say. And also 4 and 7 don't have any common factors. So that's how I knew this couldn't be simplified. But, however, this guy right here, I knew could be simplified because if we look on the diagonal, 4 and 12 can be both divided by 4, right? And that's how I knew that could be simplified. So maybe something to keep in mind there. All right, let's look at the next one. We have mixed numbers. So I'm going to first change these to improper fractions to make my work a little bit neater. And this is going to be 13/3. This is going to be 5/2. So this is the same thing as this. Okay, so now we can apply keep, change, flip. So we have keep, change, flip. Now look on the diagonals. I know that 13 and 5 don't have any common divisors, neither do 2 or 3, besides 1, of course. So I know that when I multiply straight across, I'm not going to have to simplify this. 13 times 2 is 26 on top, and 3 times 5 is 15 on bottom. And that is going to be my answer there. Okay, the last topic we're going to cover in this video is order of operations. And basically one way you can think about it is what we call PEMDAS. So this PEMDAS is, this is what I was taught. Please excuse my dear Aunt Sally. I don't know what Aunt Sally did, but we should excuse her because her behavior was uncalled for. Please excuse my dear Aunt Sally. So that's PEMDAS. And that's the order that we evaluate expressions in. So we start with parentheses or grouping symbols, and then we do exponents or square roots. Then we do multiplication, division from left to right, and then addition and subtraction from left to right. So please excuse my dear Aunt Sally. Okay, let's go ahead and just get into it. So we have 3 plus 5 times 9. So PEMDAS tells me that M comes before A. Multiplication comes before addition. So I do this part first. So this is 45, 5 times 9. And then I just carry everything else down. Last thing to do is add. So this is going to give us a final answer of 48. That's my answer here. All right, let's look at this next example. So what should we do first? We should do what is in the parentheses first, because parentheses comes first in our please excuse my dear Aunt Sally. So 4 minus 1 is going to give us 3, and we can carry everything else down. And then exponents and square roots go hand in hand. So we can do the square root of 9. If you put this in your calculator, or if you know it, the square root of 9 is just 3. So this just becomes 3 times 3. And finally, 3 times 3. Nothing left to do but multiply. That's going to give us 9. Okay, so that was that. Let's go ahead and move on to this example. So this is like a multi-step example. So we start with parentheses first and just keep carrying things down. So 3 and 9 in parentheses is going to make 12. So this is 5 plus 7 times 12 divided by 6 minus 3 squared. Okay, parentheses is taken care of. The next thing to do is exponent. So 3 squared is 3 times 3, which is 9. So we have 5 plus 7 times 12 divided by 3 minus 9. Okay. Now what comes next? Multiplication comes first because we're going from left to right. Okay, so 7 times 12 is, let's see, that's 84. So we have 5 plus 84 divided by 3 minus 9. Next comes division. So 84 divided by 3 is 28. Carry it down. And then we can just go from left to right. So 28 plus 5, 33 minus 9 is 24. So that is our answer here. Did I do something wrong? Let's see. 5 plus 7. I think I did something wrong. Now we have to figure out what it is. Let's see. 84 divided by 6. I think I did something wrong. Let's try this again. Okay, so still we're going to do parentheses first. So 3 and 9 is going to be 12. So we have 5 plus 7 times 12 divided by 6 minus 3 squared. Okay. All right, now we take care of the exponent. So 3 squared is 9. 5 plus 7 times 12 divided by 6 minus 9. Okay. Then we have multiplication. 7 times 12 is going to give us 84. So we have 5 plus 84 divided by 6 minus 9. 84 divided by 6. Let's see. 84 divided by 6 is going to give us 14. So this is 5 plus 14 minus 9. And that is going to give us 10. So that is our answer there. All right, let's do an example here. So grouping symbols, we want to just keep the top and the bottom separate until the very end. So the top, if I do what's in parentheses first, I get 8 minus 4 divided by, 5 minus 3 is going to be 2 times 3 plus 11. And then on the bottom, I can do this. Negative 2 times 13 is negative 26. Okay, so on top, I want to go from left to right with division and multiplication. So I'll start with the division. I have negative 4 divided by 2. That's going to give us negative 2. So we have 8, negative 2 times 3 plus 11 over negative 26. Then PEMDAS tells us I need to take care of this multiplication before I add. So negative 2 times 3 is going to give us negative 6. Plus 11 all over negative 26. And then on the top, if we do 8 minus 6 plus 11, let's see. I'm getting 13 on top. And on bottom, I get negative 26. So if I reduce this fraction by 13, if I create an equivalent fraction by dividing top and bottom by 13, I get 1 over negative 26 divided by 13 is negative 2. So that's my final answer there. Okay, let's do this one. So again, I want to do what's in parentheses first, and within the parentheses, I want to make sure to do multiplication before addition. So let's do that. 225 divided by 3, 2 times 11 is 22, a positive 22. So that becomes that. And then what's still left on the inside of the parentheses is 3 plus 22. So it's going to be 25. So I have 225 divided by 25 minus 4. Division comes next. 225 divided by 25 is going to give us 9. And then we have 9 minus 4 is going to give us a final answer of 5. Okay. All right, we can do this with decimals too. We just have to, use a calculator. Let's do parentheses first. Please excuse my dear Aunt Sally. 3.4 plus 0.6 is going to give us 4. So rewriting this, I get 2.8 minus 5.1 times 4. All right, that was this. Now, when I don't have a symbol in between two numbers, that means multiplication. So multiplication comes next. I have negative 5.1 times 4. Negative 5.1 times 4 is going to give us negative 20.4. So this becomes 2.8 minus 20.4. And finally, when I do this, let's see. What I get. 2.8 minus 20.4 is going to give us negative 17.6, and that's my final answer here. All right, let's do an example where we have fractions. So what I like to do again is change all my mix to impropers. So 2 1/4, 2 times 4 is 8, plus 1 is 9/4. Okay, so that's changed, that's good. And then 1 1/2, 1 times 2 is 2, plus 1 is 3/2. All right, so that's cool. So it's all changed. We didn't really do any order of operations yet. Now PEMDAS says to do division before addition. So we have to do 9/4 divided by 3/5 first. So we have keep the first times flip. Okay. Multiplying straight across, I get 45 over 12 plus 3 over 2. And I notice that I can change 2 into 12. So that's what I'm going to do. I'm going to change the 3/2 to have a 12 in the denominator. And I have to multiply by 6 to get that down there. So I do the same thing at the top, and I get that 3/2 is equivalent to 18/12. So I'll replace that here. And then adding these guys, 45 plus 18 is going to give me 63/12. And I know from this step it can be simplified because I know the 3 and the 9 have common divisors. So 63, let's see, can be divided by 3, and so can 12. So if I do that, 63 divided by 3 is 21. And 12 divided by 3 is 4. So that's my answer right there, 21/4. And that's going to be it for this video. I hope you guys learned something or reviewed something. And thanks for watching. I'll see you guys next time.